Hi, everybody. Today we're going to work through a pretty big day. Okay, so I'm going to throw this one's going to be a little bit longer, but we've got a huge kind of couple concepts, or at least we could just call it like today is like a big cumulative day where we really tie together a bunch of ideas. We introduce some new terminology. Today is a big concept day. So hopefully you're able to hunker down, and here we go for today. You'll see the topic on the top, just us discussing relations as ordered pairs. And that's not just what we get into, but we really start to tie together some of the concepts that we've addressed before, and we lay the groundwork for where we're going next. So we've got a little bit of vocabulary at the top of the page. What you'll notice is a set of ordered pairs is a form of a relation. Okay, a set of ordered pairs is a form of a relation. And so that's where you hear the title for today, Relations as Ordered Pairs. We know that ordered pairs are important because of last time when we dealt with plotting points. That ordered pairs or coordinates come because the order matters. And we've already discussed why that order matters. What I want to do today is I want to introduce the word relation to represent just a general relationship between a couple things. And now you see two terms, one in blue, one in red, that we're going to need to know as we move forward. So let's take a look at the first one, the one in blue, domain. Domain is actually defined as the set of the first number of an ordered pair. And when we plot points, we're generally plotting points on an x and a y axis. That really what domain means most of the time is that we're talking about our x values. So if you were even to think domain means x's, then that's a pretty good idea to have in your head. Okay? Alternatively, then when I see range is the set of the second number of an ordered pair, then range refers to our y values. And same thing. If we put that idea in our head, then I think we're doing well. Okay, so let's just look at a quick example right underneath that where we should be able to go through and figure out very quickly domain and range. Okay, the first thing that you'll notice, we have those fancy brackets in there. We have those brace brackets in there. And brace brackets are used to denote a set of values. So notice, within each definition, you've seen the word set. Now my guess is we probably glossed over that a little bit. We're so focused on domain, x values, range, y values, that you'll even notice right up at the very beginning, when we talked about a relation, it was a set of ordered pairs. And every time we give a set as an answer, we have our brace brackets. So we're going to get a little practice drawing brace brackets. So I'm just going to highlight over, there's my brace bracket, nice and big to denote a set. Okay, for the relation, and you see them that I just circled in green, there's 3 points, 1, 6, 3, 8, and 4, 11. We would have to state the domain. Okay, well, we can see above, domain means x values, so I'm going to state my x values. 1, 3, 4. That's my full set for my domain. I close my brace bracket, and there we go. Now, we don't have to write those brace brackets so big. When we take a look at the range then, I'm going to give a set of values, so I have my brace bracket. And now I know range, I've been told, is my y values. So I list out my y values, 6, 8, and 11. That's it for my set. Close your brace bracket. And there we go. So we've introduced a little bit of new terminology, domain and range. We're going to use that so much today. We're going to start to jump into everything being combined, and we're going to start to try to look at this stuff as holistically as we can. Okay, here we go. So what we're going to do is we're going to walk through how we can describe relations. And I want you to notice that in black, you're going to see the 4 ways that we can describe a relation. We can describe it through a process of words. We can describe it as an equation. We can describe it as a set of ordered pairs. And we can describe it as a table of values. Now, we got a little bit of experience with the table of values. And what we're going to come to see is that a table of values can be a way that can help us to determine domain and range. And that 4-step process sometimes is referred to as like your rule of 4. So, can you look at a relation and can you talk about it then in terms of, well, what is it in words? What is it in algebra, the equation? Can you see it as a table, or can we list it as a set of points? Okay. What we're going to do is we're going to kind of inch our way along on this one. So let's take a look at the description in words. Right now we're told that the value of y is 1 more than 3 times the value of x. And given what we talked about last unit, I think some of us could build the equation for that, because that would be us translating our English into algebra. So for me to walk through that one, if I was to translate that, it says y is, so equals, and now it says 1 more than 3 times the value of x. So quite often we might see 1 more than 3 times the value of x. That is 100% correct. I'm just going to argue to you that that won't be the form that you see, just because notice how our x term came second. And if we can remember back to that last section, that last unit, we like to write things in standard form whenever possible. And that means decreasing powers of x. And so what you'll tend to see then is that 3x term written first. So the most common form of that equation would be y equals 3x plus 1. The value of y is 1 more than 3 times the value of x. Okay. Well, now what I'm going to ask you to do is we're going to jump over and we're going to start working in our table. And I have 2 ways now that I could work through the table. I could take my description in words and deal with the table, or I could take my equation and build my table. Now, you'll notice that my x column, my x values, have not been inputted. Nobody's chosen those x values for me. So then I get to pick whatever I want. And we got to pump the brakes a second. Take a look inside your table of values, and you'll notice that they've told us what the domain is. I've been given the domain. And I know that domain means x values, so my x values are -1, 0, 1, 2, 3, and 4. I don't get to pick my x values. They're given for me. Okay, well, now that I have those x values, though, I could use my description in words, or I could use my equation. So a lot of people, given where we've come from, will actually find it easier to use the equation. And so on that first x value, that we may choose to sub in -1 for our x, and now calculate. Okay, 3 times -1. Now I need to add on the 1. And there is my y value. But maybe some other people will use the description in words. That description in words says the value of y is 1 more than 3 times the value of x. Okay, so I'm going to do 3 times the value of x. Well, if x is -1, then 3 times the value of x is -3. And now it tells me that my value of y is 1 more than that. So 1 more than that gives me -2. It doesn't matter how you get to that y value. We can use the equation, or we can use our words. So I'm just going to get rid of all that red and green. And what I'm going to ask you to do is to pause the video right now, and I want you to fill in the rest of that table. Okay, give it a go. Okay, and so we're back. And so maybe we're using our equation as we just did, and now to find your y value that matches up with your 0, you've replaced your x with 0, and you're going to calculate, and that gets you your 1, because 3 times 0 gives you your 0, add on your 1, 1. Or again, maybe we're using our description of our words. It says the value of y is 3 times the value of x, so 3 times 0 is 0, add on your 1. Y is 1 more than, and there we go. Okay, we should get just a little more confirmation as we go that then my next y value should be 4, my next y value 7, my next y value 10, and my last y value 13. So hopefully that matches up with our table. Okay, now that we have the table matched up, now I think you guys can see that we can finish off our range. Notice under that table of values heading, we've been given the domain. Now we can state our range. I don't think we need to pause the video on that one. I think we can just do it together. We just remember to put down that beautiful brace bracket. And we can now list out all of our y values. Close that brace bracket because it's a set of numbers, and there we go. Okay, my guess is that once we got down to that point, you guys can actually see all your ordered pairs in your table, that we can see them there. That is, if you were to go through and take that table and try to produce the graph to it, you'd be able to plot all your points. So I'm going to get rid of all that green that I just highlighted, and we should be able to list out our ordered pairs. That is, you can see your ordered pairs. There's one of them right there. So I have an ordered pair that is at -1, 2. Notice I'm back to round brackets because I'm listing a set of coordinates. Now I can comma, and now I have my next point at 0, 1, and then I have my next point at 1, 4, and my next point at 2, 7, and so on, and so on. And there we go. So there was the first time that we had to kind of go through, and we had to look at a relation in a number of different ways. Look at it in words, look at it in algebra, right, in the language of math. Look at it as a set of points in our table that we can now break down into domain and range, and then really look at it as a list of points in our ordered pairs. Okay, let's jump in and play around with the next one. Okay, now you take a look at example 2, and I've left the description in words blank. But instead this time, I've given you an equation. So this time, now what I need you to do is to go through and try to describe that in words. We notice that the range is missing. So we need to fill in that words, we need to fill in the range, we need to fill in our table, and we need to fill in our points. Okay, the only thing that I want to do together in this instance is the description in words. Because I'm going to have some people that are going to write this. X plus y is 6. And I want you to know that, yes, you're correct. But I'm going to kind of say like a, well, duh. Like that is a literal translation of what the equation is. And I might just say like I don't know if you would describe it that way. Now, I'm going to get rid of that because I think we could put a little extra to it. Like maybe we could say the sum of x and y is 6. And say that like we're just putting a little more mathematical language to it, even though we're still writing in English. That I like the sum of x and y being 6 as a better statement. Okay, now that you guys have that, I want you to fill in the rest. So fill in your range, fill in your table, fill in your ordered pairs. Okay, pause the video now. Okay, we're back. I just cleaned up my language of the top part. I wasn't happy with how messy I printed it. So now we're going through and we're confirming some things. Okay, so the first thing we notice, you've been given domain and range. So you've been given domain, so I know my X values. Now we're working our way through our range. Okay, so for me to come up with that Y value, I'm now saying I need to replace my X with -5. And I have that if I'm using my equation. So I could actually solve that equation because I have the ability to do that now. And to get rid of a -5, I need to add 5. There's my Y value. However, if we were to look back at that and say that you wanted to use the description in words, well, then you could say, well, the sum of X and Y is 6. So when I add -5 to something, my Y value, it has to give me 6. Okay, well, -5 plus what gives me 6? And there's my 11. So we could come to that Y value the exact same way, just using the words. So I'm just going to change that back into red so that our whole table's in the same color. And now we can go through pretty quickly. Like -2 plus what gives me 6? Well, -2 plus 8 gives me 6. Nice. Okay, can I confirm that? Well, in my equation, -2 plus my Y value gives me 6. So to get rid of a -2, I add 2. Yep, my 8 checks out. That's the last time we're going to deal with that. We should be able to just confirm the rest of the table. So we should get 6 on that one, which should have been pretty obvious. 1 plus what gives me 6? That's 5. And 3 plus what gives me 6? 3. Now that we have our Y values, we now have our range. There's your brace bracket, 11, 8, 6, 5, and 3. And now we can go through and we can state our ordered pairs. And so our ordered pairs then would be -5, 11, -2, 8, 0, 6, 1, 5, and 3, 3. Okay, if you have that on your page, then I think you're doing great. Great. However, we have something that's incorrect, and it's incorrect from a form standpoint. I'd like you to look back at our range right now, because there's actually something in our range that we have this written rule, or this hidden rule, I should say, one we have not discussed. When you list your range values, we always list them in increasing order. Take a look at your domain. Do you notice that all your domain values are listed lowest to highest? And if you look back at example 1, you'll notice the same thing is true. But this time, when you happen to take all those Y values and just list them out, they're actually in our range in an incorrect order. Well, we didn't know that at the time. So we were correct, we just have to change it. Okay, my lowest Y value is 3, then 5, then 6, then 8, then 11. And there we go. That on the page is now 100% correct. So we've made any change. Okay, but what do we have to now pay attention to? That I would have had some people who put an idea in their head, and that idea was incorrect. That you could read your ordered pairs from your domain and your range. I want you to notice, you can't. Notice if I tried to pair up my domain and my range, then I might say that this X value of -3 gives me a Y value of 5, because they were the first values listed in each set. Here's the problem though. If I sub -5 back into my equation, Does negative 5 plus 3 give me 6? No, that does not equal that. And if I went back up into my words, then is the sum of negative 5 and 3 6? No. So what we hopefully notice then is just that we cannot pair up our domain and range to create ordered pairs. Now, if it's the only information that we have, then we can pair them up to produce a relation that could be represented by it, but we don't know if we have the relation that is represented by it. Okay, so let's be careful on that as we move forward. Okay, let's jump into another one. Okay, what you see on is now example 3. Notice that what I've given you is now a completed table. So we have the table. But what you need to come up with, what's the description in words, what's the equation, you now need to list domain and range and the ordered pairs. I think we could actually work our way through this one a little bit. So I'm going to ask you guys to pause it and answer or fill in any of those red highlighted areas that you think you can come up with. Okay, pause it now. Okay, so we're back. So I don't know the order that we did this in. I'm just going to try to guess the order that you may have gone through, but there is no correct order to do this in. So I think that if we had the table, we may have done domain and range first, or we may have done ordered pairs first. Either one of those would seem pretty logical to me as a starting point. So maybe I do my ordered pairs first because I can see those from my table. Remember, what that says is this x value of 0 gives me that y value of 0. I know how they're paired up. So 1 goes with 1, 2 goes with 4, 3 with 9, and so on and so on. Maybe we looked at that and we said, hey, we know our domain and range because I can see my domain are x values, and that was a really ugly brace bracket. That my domain is my 0, 1, 2, 3, and 4. I can see my y values. Those are 0, 1, 4, 9, and 16. Notice that I've listed everything, all those values, in numerical order, increasing order. We're good for them. Okay, now I take a look. Do I describe that in words, or do I try to create the equation, describe it in algebra? This one may have been a little difficult as to where to get to. But maybe if we just zero in on these values, then we may have seen, hey, 0, 1, 4, 9, 16, those are all special types of numbers. Those are all perfect squares. And so maybe then we backtrack a little bit and we say, hey, well, 1 gave me 1, and 2 gave me 4, and 3 gave me 9, and 4 gave me 16. It looks like in all of these cases, my y value is the square of the x value. And what would that mean for an equation? Like, I would have a bunch of people that would write, in this case, they would go like, well, if I take x and I square it, it gives me y. So if I take x and I square it, it gives me y. And that is 100% correct. 100% correct. We would just generally see it written with the y first. But we can tell that the blue equation is the exact same thing as the red. Okay, there we go. So as we work our way through those, we need to have the ability to be able to break down every relation into words, into algebra, into a table with domain and range, and a set of ordered pairs. Okay, let's jump into something a little bit different now. Okay, when you look at the top of the page, now you're going to see that for each graph, so we've got a couple graphs here that we want to talk about. Step A, we have to express the relation as a set of ordered pairs. So I'm hoping that if you printed off this lesson, it came through very clearly, but that you see that we have these 3 points that exist. We need to express that relation as a set of ordered pairs, and then we have to write the domain and the range. So I'm just going to shrink that down a little bit so that we can see it a little clearer. Okay, and what I want you to do is I want you to go through and answer that problem. I think we have enough in our background to do it. Okay, pause the video now. Okay, and we're back. So if I was to just look at those points, maybe I'm going to label them on here. This is not needed, and actually I wouldn't want to see this in your solution. But maybe we take a look and we notice at that point, it has a coordinate at 3, 1. This point has a coordinate at 0, 2, and so on and so on. We could label them on the diagram, but we could just write them down as our set of points. Now, when we list ordered pairs, there is no rule about what order you have to list them in. So if you just listed them left to right and you said, hey, well, this point at -3, 3, I would list first. No problem. Now, the only rub becomes that now when you have to go and list domain and range, if we do not list our points first in order, left to right, then domain, it's going to take us a little bit to do it. So now we need to put down our brace bracket, and we need to make sure that your x values are in increasing order. You now examine your range. My range has y values of 1, 2, and 3. Notice that if I wrote those down left to right, then I would have written down my 3, my 2, and my 1, and we know that that's bad form. So, unfortunately, working left to right, thinking about your ordered pairs works really well for your domain. It doesn't really do a whole lot for your range. For range, we really want to look at them from the bottom to the top. And there we go. And hopefully we match up and everything's good. Okay, let's jump into graph 2. So in this instance, I've given you 5 points, and we've labeled them as A, C, E, B, D. What I want you to do, ordered pairs, domain and range. Okay, pause it now. Okay, we're back. So if I was to list these out, I would list them left to right. That means I'm going to list point A first, then point C, then point E, then, well, B and D are above each other. So maybe I just go B because it's a little bit easier to see because I have less counting. It's closest to the axes. And then all the way up there at D, would be at 2, 4. There we go. Okay. That made my life a little bit easier because now I can state my domain. Well, my domain is my set of all x values. So -5, -3, -2, 2, and 2. Now, if you wrote that down, we made a mistake. And it's not a mistake in understanding. It's a mistake because when we state a set of values, we list what are all the possible x values. Notice we repeated ourselves. We stated 2 and 2. Well, if I was to ask you, is 2 an x value of those points? Your response should be yes. I shouldn't have to follow it up with another, well, is 2 an acceptable x value? No, you've already answered that question. So when we happen to have points that duplicate values, we only state those points or those values once. So that is what your domain should look like. We have 4 values in our domain. We have -5, -3, -2, 2, and we already took care of that one. Okay, what's your range? Well, my range then is a set of values. There's my brace brackets. I want to go bottom up. So when I look at all my blue values, I'm looking for the smallest one, the next smallest one, the next small, and so on, and so on. And there we go. Now, maybe some people see even a better reason, or maybe they just see it again, of why we can't pair up our x's and our y's in our domain and range to create our points. How many values do you have in your domain? 4. How many values do you have in your range? 5. Well, then we'd be missing something if we were trying to pair them up. Okay, if we got down to that, we are doing outstanding. Now we're going to jump into something that looks very different. I want you to take a look at graph 3. Okay, I've asked you some specific questions about graph 3. And really what I've asked is the one you see in the top right. What is different about this graph than the other graphs? That's the key question for us. And that's really what we want to be able to answer. So I'm going to highlight that one and make sure that that just kind of floats there in our idea. Okay, so now we want to take a look at domain. Okay, well, what are the x values for our graph? And maybe we locate and we notice that, hey, like I have some points on here. Like I have a point right here and I have a point right here. Like I can see the little bubble there, so I see the little point. And maybe we start to go, okay, so that was an x value of 0 and 1 and 2 and 3 and 4. And we start to say, well, there's my domain. Take a look at the question that I've asked on the bottom. What about points at like 2.5? So can we go back up to the red question? What is different about this graph than the other graphs? And if we can get back to that part where we kind of acknowledge that we have a line, we don't have a series of points, then that means that I don't just have those points that I've kind of bubbled in. Like I have a bunch of points. So I have another point here, another point here, another point here, here. All those little points in between, and a lot of them, that if we were able to shade in enough of those points, then it starts to look like we have a line. Okay, here's where we're going to get very detailed. Here's where I want us to slow down for a little bit. So I want you to look at the graph that I just shaded in blue. If we were to answer that question, on that graph, what is my domain? Well, then my x values are everywhere. And if I go up here, I notice that that's at -1, and all those points on that line all exist all the way over to here, which puts me at an x value of 5. And all my x values are everything in between. Like, do I have a point with an x value of 2.5? Sure, that would be exactly between 2 and 3. So if I went up from there, yep, I have a point on that line. And so what I need to say then is that my x's can be anything between -1 and up to 5. So I'm going to bring back my good old inequality symbols and say x could be anything greater than -1 and less than 5. Now, that statement isn't exactly true, because if you take a look, at -1, I have a point, and at 5, I have a point. So I also have to include those values, which means I need my equals to. That's how we would state our domain. That is a set of x values. Everything between and including -1 and up to 5. Okay, we changed that pretty significantly. Why did it have to change? Because we had a line. Those points were now connected. They weren't separated points. By me connecting them to form a line, I created all the points in between. So can we just make sure that we get, because they are connected, that was the key. Okay, what I want you to do is I actually want you to take a shot for a second and try to come up with what you think the range would be. Okay, you're going to come up with the range for that blue line. Okay, pause the video now. Okay, we're back. So if I look at one end of that line, I notice that that's a y value of -2. And if I go all the way up to the other end of the line, I notice that that would be a y value of 16. So our y value then is greater than or equal to -2, less than or equal to 16. Nice. So that's how we can go through and find domain and range, our x values and our y values, for a connected shape, a connected set of points. Okay, this is where I said we're going to get very detailed. Now I'm going to change the picture on you a little bit. And what we're going to do is we're going to add in a purple change to that graph. So I want you to imagine now that at the end of that graph, sorry, I just jumped that graph on you. At the end of that graph, there were arrows on the end instead of it just running to the end of the line. That you actually saw arrows produce on the end that say that that line goes off forever and ever and ever in both directions. Okay, how does that impact our answer for domain and range? Well, I'm going to put a little wavy line down here because what we're going to do is we're going to answer that question for the new line, for the purple arrows. Okay, if I was to ask you, hey, what are your x values now? Then I would hope that we would say, like, our x values could be anything. Like, they could be anything. Like, even though I don't see it, if I went all the way over here to an x value of 10, it says that that line goes off forever and ever in that direction. So if it kept going up, can we see that we would eventually, even though we can't see it in the picture, we would eventually have some point up there on that line? So that means that my x values can be really, really positive. Like, they could keep going. And because of that arrow on the end, can we see that, like, even for an x value of like 1,000,000, if I went all the way over on my x-axis, like all the way over, that I could go through and eventually I would hit my graph that was going up forever. Can we also then see that if I went down forever in this direction, that we could go through and see the same thing? That eventually, if I went really negative, I would be able to hit my graph somewhere. So that means that my x value could be anything, and that line would exist. Okay, so how do we actually write x could be anything? Well, this is your notation. And I know that that looks really weird. We're going to define it a little bit. What you have is two symbols. You have that soft E looking thing. It looks like a rounded E. What that means is the element of. And that is just a really formal way of saying x is a part of a set of numbers. That's all. It's a part of a set of numbers. It's an element of a set of numbers. Now, what does the R mean? Well, in a lot of cases, when you see that R, like you'd actually see it written in a certain way. It'll take that form. We just write R. And what that really means is the real numbers. Real numbers are any numbers that you can count with. Like they have a value. It's like 1, 2, 3, 4, 5, 6. All your whole numbers are real numbers. All your fractions are real numbers. All your ugly square roots are real numbers. All your decimals, your positives, your negatives, all of that stuff you can count with. And so when we write x is a part of the set of real numbers, that is our formal way of saying x can be anything. So, how do you say it then? X is an element of the real numbers. You don't say XER. X is an element of the real numbers. Okay, I'm hoping that we can see that same thing then for our Y values. That since that line goes up forever, and since that line goes down forever, that all of my Y values could exist as well. And so I could say that my Y values are a set of the real numbers. And there we go. Okay, that is a little complex. I'm going to say if the purple is getting you a little bit, don't worry about it. We're going to get a ton of practice with that. If the blue's getting you a little bit, I'm going to say then we're missing a little bit of a concept, and we want to be able to work our way through that. But I would add in that graph 3 right now is a bit of a doozy, so that's okay. Okay, let's jump into something different. It's going to look considerably different from what we've been talking about. Okay, you take a look at problem 5. And what's happened is I've given you a graph. And on that graph, I've labeled 5 people. You'll notice that on that graph, we are comparing their height with their age. So you can see what's being measured on each axis. Age is on the horizontal axis, height is on the vertical axis. You can see what units we're measuring in. Years for age, centimeters for height. Okay. For that graph, I want you to state the ordered pairs, the domain, and the range. And I think that if you can chop off those 3 things, then that's going to give you a really good gauge of whether you have today's topic. So, go ahead. Pause the video now. Okay, we're back. So I'm going to list off my ordered pairs. So maybe I go first off to Xanthia, and I notice that she is at 6 and 120. And then I'll hop up above, and I see where Sarah is. Sarah is at 6 and 150. I then take a peek, and I go over to Emma. Emma is at 8, 150. I jump over maybe to Sam. Samantha is at 13, I think, 140. And then I take a peek, and I go up to Rebecca. And Rebecca is at 13, 170. Okay, there we go. Okay, domain then. Well, we should be able to go through and list out our domain. So my domain is my set of x values. Well, since I listed those points left to right, I can see all my x values in increasing order. And because I have a number of x values that repeat, I have a pretty limited domain. Okay, what's my range? Well, this one's going to take a little bit more work. I got to make sure I'm climbing, I'm increasing. 120, then my 140, then my 150, I double 150, then up to 170, and there's my range. So, as I said earlier, if you've got that blue written down, you got a great job. Great job for today. Okay, now we're going to jump into that second question. Explain the point 6, 150. Like, what does that mean? And so if we were to look on that graph, 6, 150 would put us right there. Okay, well, what does that point mean? Okay, well, maybe we write when someone, because it doesn't say that I'm talking about Sarah, when someone is 6 years old, because that would be their age on the horizontal axis, they are 150 centimeters tall. Now, it dawns on me that if anybody is paying attention to this right now, okay, that is a really tall 6-year-old. Like 150 centimeters tall, that's 1.5 meters. Like, that's a tall 6-year-old. If you were to go through and you were to try to calculate, like, I don't know how many of us tend to think of our height in centimeters, in metric. But if you were to go through and try to calculate that, like, that's a 6-year-old that's like almost 5 feet tall. Like, I'm going to go and start recruiting that kid for my basketball team. So I'll fully admit that that's a little out of whack. Okay, that's a very, very tall C, but that's what it would mean on your graph. Okay, can we take that graph now and can we go through and answer the 4 questions that follow? So I'm going to shrink this down just a little bit. And what I want to do is I want to go through and I want to answer question 3. Identify a student that could represent a student that is older and shorter than Emma. So we need older and we need shorter than Emma. So where is Emma right now? There is Emma. Well, we have 5 people on that graph. If we take away Emma, we have 4 people on that graph. So that means you need to identify one of those other 4 that would be older and shorter than Emma. So go ahead and pause it, and I go on the record, write down the name of somebody that satisfies that, older and shorter than Emma. Pause it now. Okay, we're back. So if I was looking at older than Emma, then I need to go in and kind of deal with the older part. Well, right now, Emma is 8 years old. So I would need somebody that would fit within that purple range. That would be somebody that would be older than Emma. But they have to be shorter than Emma. So shorter, well, Emma's 150. So anybody shorter than Emma would fit into that range. And there's only one spot where I kind of see the purple and the green, and that's going to give us Samantha. Why? Because, well, what is the coordinate? Where does Samantha fit in? She fits in at 13 and 140. So Samantha is older than Emma. Emma's 8, Sam's 13. But Emma's 150 centimeters, Samantha's only 140. There we go. Okay, I want to leave you guys with the next ones. So let's use this one as a gauge. Are you able to identify a point, not a person, but a point that could represent a student that is taller and younger than Rebecca? Okay, identify a point that could represent a student that is taller and younger than Rebecca. Okay, well, if I search for where Rebecca is, then Rebecca is here. Okay, I need you to identify a point that could represent a student taller and younger than Rebecca. Okay, pause it now. Okay, and we're back. So for me to go through somebody that would be taller and younger, well, right now I notice Rebecca is 13, so maybe I've got somebody who's 12. Rebecca is 170 centimeters tall. I need somebody taller, so maybe I go 180. I would have expected that to be a pretty common answer. Now, that's still pretty unreasonable. Like, I'm going to argue that 180 centimeters, if I was to convert that, that's 5'10", almost 5'11". That's a pretty tall 12-year-old. Okay, I want you to write down a second point. Now give me something that is totally unreasonable, like in real life, that is completely unreasonable. Can you give me another point? Okay, pause it now. Okay, we're back. Like maybe you did something like, and you went totally unreasonable. Like rather than being just younger, you went like way younger, like maybe like 2 years old. And now if you have to be taller than, like maybe you went to the very top. You say like, okay, like I'm going to say like 200 centimeters. I don't know, something like that. A 2-year-old being like 6'1", 6'2". Okay, that's crazy. But it would satisfy it. It would be a point that would represent a student that is taller and younger than Rebecca. Okay, let's try more. Okay, you guys see your last two problems. With no discussion, I want you to pause the video now and we'll see if we match up in the end. Okay, we're back. So, 5 says identify a point that can represent a student that is older and shorter than Xanthia. Well, there is Xanthia. So I need older but shorter. So maybe I take a reasonable one and I say older might be, I don't know, like 10, and shorter might be 110. I don't know. Right? Like Xanthia is 6 years old and is 120 centimeters tall. So maybe I pick something unreasonable. A 14-year-old that is 10 centimeters tall. Yes, that would be unreasonable. Maybe you take a look at question 6. Identify a point that could represent a student that is shorter and younger than Sarah. Well, Sarah is right there. So, shorter and younger. Well, then maybe we go something like 4, 130. That would be shorter and younger. And clearly then you have a bunch of other completely unreasonable answers. Okay, that takes you guys through a huge component for today. I said it was going to be a big one. We were able to look at our relations. We were able to introduce the terminology, introduce domain and range. We were able to look at them as an equation, as words, as a table, as a set of ordered pairs. We were then able to take graphs and start to break down domain and range for them. We got to talk about the difference between a connected curve, a connected set of points, versus just separated points. And then we were able to take a graph and start to find information from it. Okay, it was a big day. Your job now, jump in and get some practice, and we'll see if we can nail out some of that terminology. Okay, good luck.